Hello guys, good morning. Audio check, video check. Welcome to another episode of Xahlee Talk Show. If you are watching this offline, play at 1.5 speed because I ramble just like Joe Rogan monkey. So we are going to do Emacs Lisp coding, pure Emacs Lisp technology. Make America great again. By technology, and that's the only way. And Emacs Lisp, okay? So if you are here, say hi. Okay, let's begin. Someone here, nobody is here. So let me just code, okay? So we are going to solve this algorithmic problem. So let me tell you about it. Complan search for xahlee.info, Xah programming blog. So there is a fascinating question. So let me show you what is the question, okay? So you just search for find and replace feedback loop problem, okay? Find and replace multi-pairs feedback loop problem. I had this problem for like 10 years. Basically, the problem is if you want to do find and replace text and you want to do it multiple pairs, you cannot do it sequentially, because then you run into problems. You'll get into a situation where your find string that does not occur in the input text. However, it gets replaced by the replace string. So that is the situation. Okay, let me check one more time. So audio check, video check. Where is my audio check, video check? Okay, find, replace, multi-pair problem. So I talked about this 2 days ago in last episode. So, but let me tell you again. So if you have a text, you want to do multiple pairs of find, replace. For example, if your input text is A, B, C, D, and you have two pairs, A replaced by C, and CB replaced by X. So A occurs once, so it becomes C. So you got C, B, C, D. And CB does not occur anywhere. Okay, so CB2X does not happen. So the result should be CBCD. However, if you do this, replacement sequentially, then you'll get XCD, because A becomes C and C interact with the subsequent character. They are CB. Then CB becomes X, so you get XCD. So that is a problem. Find, replace, multi-pair problem. So I had this problem for like 10 years because this happens in real life, especially when you do, the ampersand encoding. So, it happens in real life. So I was talking about this 2 days ago in my live stream, and I was wondering, today we have AI, so let's ask AI. This problem must have happened before. Is it a known problem? Must be a known problem. What is the name? And AI answered. So let's see. Can I find my tweet? Or just search my programming blog. I blogged about the situation. So age of AI, artificial intelligence. That's interesting. So I've been super busy writing a lot of articles. If you are watching here, say hi. Okay. So coding font review, lots of work on font technology review, Wolfram language words, state of AI multiple string replacement problem. So I was, posting on Twitter and live stream about this problem. And I was wondering, I'm pretty sure this is a known problem. Is there a name for this? Grok. And Grok says, yes, this is a known issue in string processing, commonly referred to as the multiple string replacement interference problem, or cascading substitution feedback. It is often solved using simultaneous replacement algorithms like a whole quadratic to prevent order-dependent errors. Amazing, So AI told me I had this problem for 10 years. AI told me the name. Then I searched for the name. For example, this another AI. This is Brave browser, Brave search. I recommend it. Okay, don't use Google. Don't use Firefox. I recommend Brave browser. It has add filter building, add blocking building. Okay, Brave browser and Brave search, I search for multiple string replacement problem, and Brave answered. So Brave gave you two solutions. One solution is that you use a regular expression to join all the find strings. Okay, so all the find strings, you want to find this or this or this, regular expression. Then you put the find and replace pairs into a hash table or dictionary, also known as dictionary. So you search for the regular expression for all the find strings. Once you find it, you check which one you found. Then you use the dictionary to find the replacement for that found string. Then you replace that. Okay. So this is fantastic. This is doing find replace in one shot using regular expression or. So you don't have this feedback loop. So that's one solution I haven't thought of. Okay, so that's one solution. So I learned something from AI. AI is, it's like 100 professors around the clock serving you. That was one of my my fantasy when I was younger. Is it, can I have, I'm deeply obsessed about knowledge, so I want to know. It would be great if I have all the professors around me who can, whenever I have whatever question, math question, the math professor will answer it. Let's say the world's top mathematician, he'll just answer it. I have a question about chemistry, about society, about whatever, programming, computers, or CPU. All the professors will answer it right away. Or about plants, the plants or flowers, or English literature, history, linguistics. It would be amazing. All the professors of different fields, hundreds of them, evolve around me whenever I have a question. So you have to be very rich to do that. But anyway, today we have that. That is AI. So I've written about this age of AI. Professors on demand. That's exactly what AI is. It's pretty much. Basically you ask anything you don't know, like anything in history, in academia, any academic topics, history of, let's say, history of salt. Can you pass the salt? History of salt. That's there's a history to that. Or the history of pi, the mathematics pi, the number pi. Or the history of, any math or any mathematics or history of, or any linguist. You can ask the history of Mexico. How many races are there? Things like that. Like things you don't know a thing about. You can ask. That's AI today. Okay, so that's AI. Then there is resistance to AI. Okay, so typically the European Americans, like they they got a problem. But it's interesting. Let me finish talking about this, and we will get back to Emacs Lisp coding. Okay, so because there's a resistance to technology, and I personally see it. So, for example, when there is graphing calculator when became popular around 1991. That was when I was in college. There's a huge debate whether you should allow using graphing calculators. Oh, that's like, if you a student these days are too lazy, because graphing calculators, you don't learn anything anymore. You just punching the numbers. And then I learned, through lots of readings, diverse random readings, that happened. The resistance to technology happened in typewriters. For example, when mechanical typewriters were invented 200 years ago, people are saying, "Oh no, thank you. I'm capable of writing, handwriting, like they are resistant. Like, what the fuck? Yeah, I don't want it. I don't want mechanical type, I don't want typing machines. I can hand, writing by hand beautifully. That happens to typewriters. That happens to credit card. When credit card was invented, people are like, no, I'll stick to my checks. Thank you. And when calculator were invented, there are a bunch of engineers there. No, thank you. I'm capable of using the slide rulers. They used to use the slide ruler. So then graphing calculator and instant messaging, I personally experienced. That's around year 2000. When all of a sudden you have the instant messaging, AOL online, like of course, today we have Twitter and so much others. But when instant messaging came up, you can instantly chat to someone on the internet. Maybe your friends in another state or in another country, you can do that. Then also when Wikipedia began around 2003, there's huge resistance to Wikipedia for like a decade. All the tech nerds, they refuse to link to it, and still, and there's still some of that today. So, but eventually, technology, you cannot stop technology. Okay, like today, a lot of people are, especially the white Americans, they got problems. They are resistant to AI. The AI is just all fake news. It's controlling your thought and all that. They make people stupid. Or some research. Look, the scientists, they did the research. All the people, students who used AI, they are unable to think. Okay, those people who say that, they are idiotic. They are the Luddites. So there's a story about Luddites, however you pronounce it, they are resisting to the invention of the weaving machine, and they get angry. They start to burn or break machines. The most famous story, Luddites. Okay, so there's strong resistance to AI, and then Wikipedia, and but eventually the resistance fold, because you can never stop technology, the progress of technology. For example, chopsticks. You know what's a chopstick? Or fork and spoon, or knife, or the wheel. The wheel, the greatest invention, the wheel or the fire. You can never stop it. Okay, or today the internet and cell phone. The internet, I remember when internet began around, let's say, 1991, I began to kind of start to use internet in 1991. You have to connect to modems, you have to buy modem anyway. So, but then they start to have email. And a lot of people, back then, that's cyberspace. What is email? A lot of people refuse, of course. But today, we are beyond email. Of course, everyone is on Twitter. Everyone is on Instagram doing their whatever shit posting and whatnot. So, technology, you cannot stop it, okay? If you don't use it, somebody else will keep using it, and you'll be, like, dead. Such as nuke. Okay, so in AI, so anyway, so that's a digression about AI. So we got into that story because we were talking about, I asked AI a programming issue, algorithmic problem, and it answered superbly. A question I had, I didn't look into, but it's a question I have for 10 years, and AI just gave me the answer. Okay, so there are two solutions to this problem. One of them is the where is the article? One of them is the where's my blog? Okay, so I need to go to show that article again. So one of the solution is you create a hash table. You use regular expression or expression to do them one shot, and each time you found one item, you use a dictionary to find the replacement and do it. That's one solution. The other solution is can you see it? It's kind of small. So the other solution is the AI from Brave Search, which is called Leo. Leo answered is that the other solution is you do a twice substitution. You substitute twice. So the first time you replace each find string by some kind of random number, okay, that will not occur anywhere. Basically, you identify all the find string spots. Then the second pass, two-pass solution. The second pass, you use your newly random identifier to replace with each of the find string. Okay, two-pass solution, and that is what I was doing. Okay, so that is the prelude to the problem. Okay, so let's begin to write the code. So I started talking for 15 minutes. Okay. So what we want to do, okay, so what is this programming blog? Okay, so today's talk show. So let me show you the code, okay? So I got this command. So describe function xahlee replace Greek letter name to symbol. Okay, so here's the documentation. Let's go to it. So you can see you have bunch of, so let me demo. So here's the source code, but let me demo. Okay, so open that, close that. Let's start to demo. Text. Okay, so let's text. Okay, so you have some Greek letters, such as alpha and beta. Suppose you have a angle of theta, mathematics, okay? So now you copy that. So, but you want the real Greeks. So what you can do is xahlee Greek. What is this command name? Xahlee replace Greek letter name to symbol. Do it. So you can see they become alpha and beta. Okay, actually you need to do this on this line too. Theta, eta. Okay, so actually I need to fix that. So you see there is theta and there's eta. So, but when you call this program, it didn't check the word boundary, so it all became eta. And actually, I think eta is not in modern Greek. Eta is am I correct? Ancient Greek or something. Okay, so let's look up. So now let's go to Unicode blog. Okay, and there is a section on Greek. Of course, you can go to Wikipedia. So so there's eta, bold, italic, cancel translation, Greek, archaic Greek letters. Okay, so you got the final sigma, cancel that. Cheers, red wine. So eta, where is the eta? So God, is anyone here? Hi, Rohan. Why the half keyboard in the middle? That is for my keyboard macro. That is ultimate hacking keyboard. There are two parts. You can see them, but I can, so you can see the other part is here. So I use them as a keyboard macro. Okay, for example, so I'm in, in my browser, so this key switch to the last tab, previous tab, next tab, previous tab, next, previous, next, previous, boom, close it, reopen it. Oh, wait, where's my reopen key? Wait, I think I removed it. Okay, tab, Shift Control T to reopen. Okay, where's my reopen last? I forgot. I probably removed it when I changed my keyboard layout. Okay, that is the answer. Yeah, so I've done like hundreds videos about keyboards in the past few years. So it's on my YouTube. Okay, so let's go back to Greek. Yeah, so we were wondering what is eta. Okay, so let's check on that. Now, is eta a archaic Greek? I thought so. Does anyone know actually? So archaic Greek letters, math symbols derived from Greek. Wow. Okay, so let's check Wikipedia. Greek. Greek alphabet. Okay, so we are looking for eta. Now, does it, so it says here, search for ETA. Beta, zeta, oh, that's H. I mean, that's corresponding to the English H, or looks like. Okay, that's why. Greek capital, okay, so eta. So anyway, so you can see, so go back here. So we got this eta, so we need to, when we do replacement, we need to have a boundary check. So we, theta would not become th eta. Okay, can you see that? So, okay, so that's back to the command. So we want to rewrite this command, okay? So let's do that. Okay, I think we talked too much. I mean, not be able to finish this. Okay, so we start the Emacs Lisp code. So let's start coding it, okay? So right now it's calling my custom function, which I talked about before. You can download it. So this sub replace pairs region, so you can see how easy, convenient. So you just say, give it a list of find replace pairs. And this function is available online by just go to describe function, go to the source code, go to the top. So it's on this URL, open it, showing browser. Wait, undo. This key showing browser, okay? So you can, so the source code is here, you can grab it, okay? You can use it. But I want to change it because, close, I want to change it because I don't want function dependency, because to enable to use this function, you need to get that library. So I don't want that. So that's why let's rewrite it, okay? So let's do that. And also we need a boundary check. How many people watching? 2 people. Okay, so let me just focus on this and get to work. So do we have the algorithm outline? Yes. So all you have to do, I have written it here. We want to find replace multiple pairs. Each find string is not regular expression. Now remember, we don't, the find string are not regular expressions, okay? Because when you have regular expression, then you don't have this sequential replacement problem, because each regular expression can match arbitrary kind of thing. So if you have multiple pairs of regular expressions, like find replace pairs, and each find is a regular expression, usually you just want to do that sequentially, okay? So, but in our case, it's not regular expression, okay? So we want to do find replace multiple pairs. Each find string is not regular expression. Input is a list of pairs. Each is a find replace string, okay? Convert the find strings into a list, then call regular expression quote on each, so that they are not a regular expression, Then combine into a single regular expression using OR. Okay, so that is an outline of the algorithm. Let's with OR operator. Okay, then call a regular expression search forward to replace them in a while loop. For each found, replace it by the corresponding replace string by checking what's match string. Okay, so that's the outline of algorithm. So let's kind of type it. Okay, so where is our code? Here is our code. So let's describe the algorithm here. Okay, so let's yeah. Something like that. Okay. Now begin. That's begin and end. That's a position, the cursor position of the region we want to do the change. Okay. So in this case, so if it's given in the argument in the parameter, then use them. Otherwise, but let's do something. Okay, so actually, let's set queue, set sequence. Okay, so actually we have written this before. So let me grab the code. Okay, because we don't want to waste time to write this. If you don't know, I've written this in my live stream 1,000 times, so we don't need to do it again. So let me just grab it. So what is this? Let me find where I can find that code. Okay, so oh god, so this is not actually let me just find it. Okay. No. Okay, so that's one of these. Yeah, so let's copy that. Okay, close. Okay, I'm gonna explain. Okay, so close that. Okay, so that's what we want to do. Delete that, and I'm going to explain this. Okay, if region, let's format it, prettify the code. Okay, so we have a local variable x begin and end. Those are integers. That's a beginning position and end position of the cursor. Of the region, we want to do this replacement. Okay, so if region is active, that means if there's a selection, then set them to the beginning and end. Okay, but also actually, but we need another if statement. Okay, if and if they are defined given in this the argument, if they are given, then all you have to do is just say list, just return that. Okay, then otherwise, okay, so if they are given as argument, just use that. Otherwise, if region is there's a selection, then use a region beginning, region end, the selection. If there's no selection, then what you do is you search backward for the blank line. So that is this search backward. The new line. You search for two new line characters. Okay, then you return that. That's a beginning position. Then you search forward for two new line characters. So basically what that does is select the current block of text, okay, separated by new lines. Okay, so that sets up the begin end position. Okay, so then we don't need this. Okay, we want to, if there's no selection, we just do the current block. Okay, then here is what we want, the find replace. And here so this is where our algorithm is interesting, the algorithm outline. Okay, so remove that remove that. So this is our list of pairs. So let's see. So can we actually? So let me do something. Okay. So let's make it kind of one. Okay, one is lowercase, one is capital first word. Okay, so this is a list of pairs. So what we want to do is now again check convert. So this is a list. Okay, so actually, so okay, let's define the list locally. Okay, so case for search neo. So that's the list. So you need to find replace map. Okay, that is like the dictionary you want to do. Okay, and find replace map, you can set them by this list. Okay, now prettify. Okay, that is your find replace map. Okay, now how do you deal with the lowercase or capital case? Right now I'm saying, make it case sensitive. Then manually, you have this group of capital letters. Yeah, let's do that. No case for search, set it to neo means no smart case. It's just all case sensitive. Okay, so that's that. And so what's the next? So you need to grab. So let's see. That's too many words. Okay, so let's just say FP map. Okay, that's our find replace map. Copy it. Then so algorithm outline, that's correct. We want to change them. So find strings. Okay, you need to get all the find strings. Okay, so find replace map, find strings. Okay, okay, so you want to gather all the find strings. Okay, so what can you do is you map. This is how you do, not map char. So you want to map car. That means go. Basically, that just means map, like Python's map or JavaScript, like JavaScript map. Okay, so you want to map to this sequence, and what is the function? The function is just to get the first element. Actually, you need to turn this into a hash table. Oh God, there's a lot to do. Fuck. God, there's a lot to do. Okay, so let's do it. So, okay, find string, set all the find strings. Then, what do you want to set them to be? You want to set them to be a list. Okay, so all you have to do a ref. Because those are arrays, you can see these are arrays. So you want to get the first element. Array, which is x. So yeah, each pair is an array. So array index is 0. Okay. So that set find string. Find string is you can actually print it. Okay, so wait. You want to print find string. Okay, that's a find string. Actually, so let's see, why is this so that sets the sequence. Oh god, a lot to do. So we need to finish this quickly. So why is this indented one level to the left? Let's increase the that's the let. Oh yeah, so that's why. So this no wonder. You need to be very careful about this, because this is the let block local variables. You see, so this needs to be inside. So prints that. So basically, it's a list of find strings. Okay. And also, you need to turn this into a map. Oh god. So right now, it's a list of pairs, and each pair is an array data type. But for this problem, it's better if you turn them into a map, like hash table. Okay, you need to turn this into hash table. God, oh fuck. So let's go to Emacs Lisp tutorial. Hash table is a data structure in Emacs Lisp. Emacs efficiency. We need to go to Lisp basics. So sequence data type hash table, there it is. So that's your hash table, and you want to create a hash table. Okay, so what you can do is make hash table. Okay, copy that and close that. Okay, so this right now it's a list of arrays. You want to make them into a hash table. So there, first of all, there is a design issue. Do you want it to be like manually hard code a hash table to begin with, or you can begin with a list of arrays which is easy to read, then have a function that turns them into a hash table. Let's do the function. Okay, so yeah, so then you need another variable. Let's say hash table. Okay, so yeah, so this hash table is actually a hash table. Make hash table. Okay, then you set hash table. You want to turn this into a hash table. Okay, can you do that? Yeah. So okay, so you want to turn it into a hash table. Okay, so you do map C. Then what sequence you want to map to? You want to map to this map. Okay, then in the body you say put hash table. For each item you put hash table. Okay, create hash table with symbol keys, with integer keys. In our case, the keys are string keys. Okay, so literal expression for hash table length add entry. There it is, add entry, put hash. Okay, so the body of the function is gonna be put hash. Okay, no make hash table. Wait, where are we making hash table? No, just put hash. So put hash, the key will be the first element of the array. That's called vector in Emacs Lisp. Okay, so the first element of a vector, how you get the first element that would be array f. Okay, so array would be x. The x is a pair, because we map it to that. The index is 0, so that is the key, and the value would be not 9, the value would be the first index of that array, okay? Then here is where you say the hash table, put it to hash table, okay? So prettify the code. So this line, this single line, will turn this list of vectors into a hash table. It populates the hash table, okay? Convert a list of vectors to hash table. And no expansion found. Interesting. Okay, so hash table. Okay, that's this line. So we got the hash table. Let's highlight it. Okay, so this map. So we got a hash table. Fantastic. It's like I've been coding Emacs so much. I know what to do. And don't. Okay, so anyway, we got a hash table. And okay, convert fine string to a list. We did that. Okay, so let's move this part to cut. Okay, yeah. So comment out. Okay, we converted to hash table. Convert. Okay. I mean it's a list of fine string. Then we also convert it to hash table. Then we need to turn this fine string into a regular expression of all. Okay, how do I do that? Well, you can call a function called rejects something, but I forgot. So let's look up I know where to find it. Create a major mod. Okay, but if we don't know, if you are not familiar with my tutorial, how do you find it? So we can do a propose to search for it. Okay, for example, let me show you the command. The command is called a propose command, which will list all commands containing certain regular expression. Okay, but right now you don't want just command. You want to find in the space of functions. You want to find a function. You are looking for a function that will turn a list of strings into one single regular expression. Okay, there is such a function. So how do you find? Well, so you do what you do is you give a universal argument. So rejects. Okay, let's just search for it. Okay, so I'm not talking about all the things. You probably don't know what I'm saying because I was not too careful in explaining. But anyway, so you call universal argument, which means you press Control U. Then you call the propose command. That will list all command and functions that contains the word rejects. Okay, that's what we did. For example, close it. So press Control U, universal argument. You can see in the bottom, Control U. Then you press the key for a propose command, which is that. Okay, then it asks you to type. Then let's type rejects. What? Let's do it again. Oh God! Wait. Didn't. Wait. Word list or rejects. Okay, so you have to type rejects. Okay, so there it is. So you got all these functions. We are looking for a function that converts a list of string to one single regular expression with all. Okay, so there's like hundreds of them. So if you are coding Emacs, this is how you find the functions you need. Okay. Cheers, red wine. Okay, there it is. Can you see that? You got rejects builder, regular expression builder, and rejects opt. Funky name. So function. This is a function. Return the regular expression to match a string in the list of strings. Exactly. That's what we want. So go to it. Return to open it. So here's a documentation of this function. Rejects opt. Return a regular expression to match a string in the list of strings. Can you see that? What? Let's do it again. Okay, so let's highlight this word. Okay, so each member of strings is treated as a fixed string, not as regular expression. That's what we want. Optional parent specifies how the returned rejects be surrounded by grouping construct. Okay, in this case, so let's just do that. So we want it to be grouping construct. That's basically means boundary. Do you want boundary? Yes, because we had the eta versus theta issue, because eta occurs inside theta. But if we add boundaries, then that's not considered the same when eta is inside theta. So anyway, so words or symbols. So let's see. Okay, so let's words or symbols. That's always a bit confusing. Symbol basically means including a hyphen, usually, not always. Let's use symbol for now. We can always change. Okay, let's do trial and error, because So anyway, so what? Okay, let's try again. Describe function rejects opt. Okay, so what is a function name? So let's just copy that, and optional parent is gonna be that. Okay, and strings is gonna be xfind strings. Fantastic and beautiful. So actually we can print this. Okay, so let's say messages and just print it. Okay, so this is our rejects. Okay, find all these strings in a regular expression. Okay, so what is it? So we need to set it. This is a list. Okay, so actually this is not a good name. So this is a list. This is a string. Okay. Okay, so let's change the name. Replace xahlee find strings by find list. Okay, do it. Okay, so you need to set that by that. Okay, fantastic, and we print it. Now prettify the code. Fantastic. Now make a backup, go to the directory, byte compile. Is there error? Yes. Lexical binding directive. No lexical binding directive. So let's add one. Use the abbreviation feature xah UTF, and it adds this declaration code UTF coding UTF-8 encoding and lexical binding true. So make a backup, go to the directory, byte compile it. Yes. Warning, unused lexical variable x begin and x end. Is that correct? Yes, that's correct, because we haven't used it, but let's ignore it. Okay, so open the byte compile file, delete it, we don't need it. We just haven't used that yet. So now the algorithm outlines. So let's see. Okay, this is fairly technical and boring. Okay, so let me finish it. xahlee find list. So convert list of vectors to hash table. We did that. Yes, that's required. And we need to. So what is so evaluate the buffer. Now let's call this. Okay, and let's just call it on this kind of here. Let's see what we do it. Okay, now go to the messages buffer. Here is what it printed. Fantastic. So you can see our regular expression. It generates this string, this long string, of or, that's the regular expression or, and also with the, so alpha, beta, chi, that's fantastic. Close it. Yeah, exactly. So far so good. Yes. Next. So next we need just go to, now let's start to use, go to char, x begin, that's the beginning position we defined here. Go to char x begin, then do a while loop, while we want the regular expression search forward. So research forward, regular expression whenever this is true. So what we want to search? We want to search for this, this is a find list. Oh, this should be find string. Okay, so so that is find list. This should be find string. Okay, actually, copy that. You see, remember we are turning a list into a string. So this is a new variable. We need to put it, So we begin with a map of list of vectors. Each pair is a vector. We create a list of just a find string. We also create a string of regular expression. So let's change that to find rejects, okay? Do that. Fantastic. Now it's more sensible naming. So we turn the list into a list of strings into one single string of regular expression. Then we print it. Then we go to the beginning position. Then we start to do the search. And what is the regular expression? That would be this rejects, okay? Bound, yes, we want the boundary. That is, don't go beyond that. So the boundary is x end, okay? Whatever the region, beginning and end. No error, true. In case, any of these alpha doesn't occur. We don't want it to say, oh, error cannot find alpha, omega. Okay, and count, we don't care. Okay, so the no error true, we can make it a symbol, easier to read, okay, which still means true, okay? So while that is found, you replace it. Now, what you want to replace here is the new text, okay? What you want to replace is that you want to find out, first of all, what is a match string. So match string, you find the exact match string, so 0, okay? So that is a match string. Then you want to get from the hash table to find the corresponding replacement string, okay? So what you do is, so hash table, let's go to hash table again. So how do you get a key, the value of a key from hash table? So that would be get hash, okay? I'm pretty sure it's get hash. There it is, get hash. Okay, so get hash, exactly. So the key is the match string, and the table is not hash table, so from this hash table. And optional means if it's not found, what do you want it to return? We don't care, just return nil. Okay, so if that is true, so when it's found, it's gonna be there for sure because the way we worked on this. So replace match, replaced by this string, okay, the value of the corresponding replacement. Then new text. Then what is the other option? New text. Let's check the documentation for replace string. Oh, new text, yeah. So new text is that, okay? Then optional, fixed case, true. Wait, it's just that literal true, and this we don't care, okay? Okay, so prettify the code. So there it is, our code. Actually, I think we done. Oh, fucking, did we already do 1 hour? Yes, but it went smooth, so actually I think I'm done. So this message we don't need anymore. Remove the message, the cost. Okay, so actually we don't, the algorithm outline we also don't need anymore. Let's kind of delete it. Okay, so that prettify the code. I think that's it. So you can see our beautiful code. Replace Greek letter name to symbol. Okay. You got beginning end position. You got, don't, make it case sensitive. Okay. Then you got the map of what you want to find and replace, capital letters and lowercase. Then you have a local variable of the list of find string. Then you have a regular expression for all the find strings in one string. Then you have a hash table of find replace pairs. Okay, so you begin by set the beginning and end position of the, if there's selection, use that. Otherwise, do the current block of text like a paragraph. Okay, then you set up the find list. So it's fantastic, perfect coding. Find list, that's all the find strings as a list. Okay, then you do convert the list of vectors to hash table. Yeah, you create a hash table. Okay, then you create the regular expression, the or regular expression or connectives. Then go to the beginning, then do a while loop. Regular expression search. If you found this regular expression found to the end of the position, no error, then you replace it. Every time you do it, found it, you do the replace by the corresponding entry in the hash table. Am I correct? Double check. Yes, I think. Okay, so backup, go to the directory, compile the file, no error, open the compile file, close it, delete it, close it, evaluate the buffer. Now we can test it. Okay, describe function, this function, fantastic. Now this is in our temp file, fantastic, So now let's go to some file where let's go to some talk show there. Okay, so copy that, paste it, and let's call the command. There it is, meta x. Let's do it. Let's see if it makes error. So do it. Wrong type argument, hash table p. Okay, we got a problem. Go back to our code. Go back to our drawing board. Is this our code? Yes. So wrong type of argument. What is the error? Replace match wrong type argument, hash table p. Oh, right. So we need get hash. Hash table. Oh, right. So wait. Oh, wait. This is not how you do it. So you don't set it, okay? Because this is not functional programming. When you use put hash, you map a function. You map this function to this map dictionary of find replace pairs. Each time you map it, you have a function you add to the hash table. So you don't actually do this set because the result of this map C is nil. Okay, so you don't do that. So the code here is correct, still correct. You just don't set. Okay, this is a part of Lisp that's not functional. Not exactly functional programming, because you see, anyway, evaluate the buffer, close the message buffer, go back to our testing page, call the command, do it. Fantastic! You see it changed the theta character to the Greek theta and did not make a mistake like before, where it changed the eta to, the eta part of theta to the eta. Let's magnify. Can you see it? So this is fantastic and beautiful. So let's do it again one more time. Copy it, paste it here. So you got alpha here, beta there, and theta. Let's add omega, okay, and pi. Okay, now let's call the command. Now don't highlight anything. It'll automatically work on the current paragraph. Okay, call the command. Replace Greek letter name to symbol. Do it. Fantastic. Theta and omega and pi. Okay, thank you guys for watching. That is fantastic. ACP says, hello, just got here. I'm almost done. Yes, can you explain the regular expression search is xfind rejects Lisp? Okay, I actually explained them in detail, but quickly. So the regulation. Okay, so we first of all we got this find list. That is a list of strings of all the find strings. Okay, how we get that? Because we just map over the map. Okay, you see, this is the original input. A list of pairs. Each pair is a vector. Okay, that is the map. Okay, so we create a find list of strings of just the find strings. Okay, then let's highlight it. Okay, so wait, highlight it pink. Okay, then here we create one single regular expression string. This xahlee rejects. How we do that? By calling this rejects opt function. It will take a list of strings and will basically construct one single long regular expression of all the words. So that is that. Okay, let's color it. Okay, so it's green. So now we just search for word. This reject regular expression is like one single huge regular expression of all words. Okay, thank you guys for watching. If you like, let's put it back, show in browser. So that's today's talk show. That's a code. This is Supreme code. Wait, syntax color it, show in browser. Scroll down. So here's a code. You can grab it. You can do. So this specific code does the find replace of Greek letters fully spelled into actual Greek characters. But you can change it to lots of use. So let me show you, for example. So let's list matching lines define. So you can do LaTeX to Unicode. You can do text to LaTeX, convert, or math symbols to Wolfram language, or Greek letters to symbol. That's what we did. Or you can do also remove vowels, English vowels, A, E, I, O, U. Or you can replace all abbrev. You can replace all profanity. For example, let's look at the code. Fuck, shit, ass, so that they all work in the same principle. But you see, my functions, they are calling my custom function, xahlee replace pairs region. But now you don't need the dependency. You can use that, too. But we have this algorithm concrete version worked out. Okay, thank you guys. Yeah, so if you like my stuff, you can, donate me. Please go to xahlee.info. All the way at the bottom, you can see my Patreon, Amazon gift card, PayPal. If you work in a job, pay me $100. Okay? Bye, guys. Yeah, this is fantastic because, okay, let me talk for 2 more minutes. We're gonna shut down. This is fantastic because my code, let's go back to the code, this xah replace pairs region, they are inefficient, because what I was doing is the 2-pass solution. So I was doing for each pair, I'm basically doing the first replacement, but replace it by a unique random identifier. Then I'm gonna do a whole find replacement for the second pair, like going through the entire input text. Then I'm gonna do the third one, then the fourth one, and so on. So I'm doing find replace like multiple times. That's very inefficient. Then once it's done, then I go through each pair again by finding the unique identifier randomly generated, basically a random sequence of numbers. Then I replace them with a real replacement character. So my code, this is a 2-pass solution, is actually, compared to this solution we are doing today, is inefficient. So that is why I'm doing this today, to first of all get rid of the dependency. So this function, there's no dependency of my code. But it also prepares me to fix my code so I will be using this new algorithm in my package. So this package, let me show you again. So this is xah find replace pairs.el. It's great, very useful, because instead of manually writing this whole thing, you can just simply say, just give a list of find replace pairs you want. And we were talking about earlier today, I learned this because by happenstance, I asked AI. AI just gave me the solution. I already have the solution. The 2-pass is one of the solution, but there's another solution which is using a hash table dictionary and using the regular expression of all. Okay, bye guys.